Okay, so oftentimes in physics, you're going to have multiple equations with several unknowns. And the rule in algebra is that if you have two unknowns, you have to have two equations in order to be able to solve for your unknowns. So there's two methods that we use to solve for unknowns when we have a system of equations. One is substitution, and that is one that most people love. And then there is adding, subtracting equations. And there's actually a third one of dividing equations that we'll get into later on in the class. So let's just review substitution. Substitution is this concept of taking one equation and isolating a variable and then substituting it into the other equation. So I am going to employ this. I'm going to take this first equation and solve for x. And so I would do that by saying 3x is equal to negative 15 minus 6y. Then I would divide both sides by 3, and this would get me x is equal to negative 5 minus 2y. And now that I have an equation for x, I can take this and plug it in right there. So this is going to be 5 times negative 5 minus 2y minus 3y equals 1. So just be careful with your, when you're multiplying out to keep your negative straight. So this could be negative 25, negative 10y minus 3y equals 1. Combine our like terms. Oopsie daisies. So negative 25 minus 13y equals 1. Add our 25 to both sides, so I get that negative 13 y equals 26, and y comes out to be negative 2. And now that I have the value of y, I can take this value here and plug it back into this equation to determine what my x value is. So when I do that, I get that x is equal to negative 5 minus 2 times my value of y, which is negative 2. So x is equal to negative 5. Negative 2 times negative 2 is a positive 4, and that leaves me with x equaling negative 1. So that is one way to solve for unknowns. So if you have two equations and two unknowns, you can substitute. The other method is adding and subtracting equations. And so this method has you manipulate one of your equations such that a variable has a common factor. So in this situation, I have, let me do this by color. I have 3x and 5x, and I have 6y and 3y. And so you can easily see that, 6 and 3, those could have a common variable if I took this second equation and multiplied it by 2. So what I'm going to do is I'm going to go ahead and take this second equation and multiply it by 2. So I'm going to multiply both sides. Math says I can do that. It says I can, as long as I do to one side, that I do to the other side. So 2 times 5 is 10x, 2 times negative 3 is 6y, and then 2 times 1 is 2. Okay. So I have just increased that equation by a factor of 2. So I have my original equation, the first equation of 3x plus 6y equals negative 15. And now I have my second equation, which I've manipulated a little bit, to be 10x minus 6y is equal to 2. And in this case, I've got positive 6y and negative 6y. So if I added those two equations, I'd get 13x is equal to negative 13. X is equal to negative 1. Pretty straightforward. And now I would take this value, and I could plug it into either one of these equations to solve for my y value. I'm just going to go ahead and plug it into that first one. So the first one was 3x plus 6y equals negative 15. So that's going to be, let me go here, 3 times negative 1 plus 6y equals negative 15. Negative 3 plus 6y equals negative 15. I'm going to add 3 to both sides. That gives me 6y equals negative 12, and y is equal to negative 2. So same solution that I had before.